Here is what the problem says.
Peter drops his calculus book from a window that is 20 meters from the ground. At the ground, just below the window, is his friend Mike, who needs his book to make his homework. So, point A. Write down the position function of the calculus book.
So what we first need to do is to define the formula of the position function, which is s of t equals gravitational acceleration times time squared over 2 plus initial velocity plus initial height, and then we substitute the values, which gives us as a result of a position function of minus 4.905 meters per second squared times time squared plus 20 meters.
Point B. Find the velocity function of the calculus book by using the limit definition of derivatives.
After knowing our position function and the formula of limit definition of derivatives, we can substitute the values of the position function. After substituting the values, we have, as a result, limit of h approaching 0, minus 4.905 x plus h elevated to the second power, plus 20 meters, plus 4.905x square minus 20 meters, and all of that over h, and also taking into consideration that x equals t. After proceeding to solve the mentioned, we are given the value as a result of minus 9.81 meters per second squared times time.
Point C. Find the acceleration function by using differentiation rules.
Using again our position function, we can use it to derivate in order to get to our velocity function, so that we could derivate it into our acceleration function, which is later on going to result at the gravitational acceleration equals minus 9.81 meters per second squared.
Point D. Calculate the velocity of the book after 1.1 seconds.
By using our velocity function, we substitute the value of time to 1.1 seconds into the function of velocity of time equals minus 9.81 times 1.1 seconds. So the result of the velocity after 1.1 seconds is going to be minus 10.791.
Point E. What is the velocity of the book when Mike catches it at the height of 1 meter from the ground?
First, we're going to find the time that has passed in a 90 meters fall. So in order to substitute that value of time in the velocity function in t. So first what we're going to do is that we are going to find our position function and then equal that to 1 meter. Then we are going to isolate t, resulting as a result of time equals 1.97 seconds. Then we are going to substitute that time into our function of velocity, which is going to give us a velocity in time equals minus 9.81 meters per second times 1.97 meters per second, thus resulting us as velocity in time equals 19.30 meters per second.
Point F. With how much initial velocity should Peter throw the book to arrive in the half time of the dropping?
First of all, we need our position function, and then we need to equal it to 0 in order to isolate t, and then later on we are going to divide it by 2 due to the fact that they ask us the half time, and therefore our result is going to be time equals 1.009, and then we're going to use again our position function and then substitute 1.009 seconds into t, and then we are going to conclude that our result is going to be minus 15.006 meters per second.
Now we know that we can use the knowledge of physics and calculus to solve certain cases.